Hi, my name is Joe Guadagno. We're here to talk about application architecture patterns. I am a senior director in technology at Rocket Mortgage. I lead quite a few teams in our trade management area. I'm also on the board of directors for the .NET Foundation right now, currently the vice chairperson. A little bit about me, you can reach out to me in any one of these ways, Twitter, Facebook, LinkedIn, my site, which has a lot of articles highlighted here. Let's get the laser pointer out, highlighted here. You can find some of my code samples at my GitHub repo, as well as videos of presentations like this and when I was streaming on Twitch. You can also reach out to me at the email address below. Enough about that. Today we're here to talk about software patterns. Now, I'm going to introduce about 15 or so software development patterns. And the overall goal is just to give you a reference as to different ways that you can go about tackling software. As Dave talked about, software quality is a big challenge in our industry. So following certain patterns allow you to mitigate some of that risk when it comes to software development. So we're going to cover these. But one of the things I want you to get out of this, the purpose of software patterns are so you don't really reinvent the wheel. Software architecture patterns are very similar to design patterns, except they're generally broader in scope at the architecture level, meaning you're looking at ways for your application to talk with each other or even just internally interact. So let's get started with our first pattern. So the first pattern has been probably one of the most common patterns around. It's been around almost as long as I've been doing software development, for at least 3 weeks now. It's the layered or multi-tiered or three-tiered. The reason why three-tiered is in quotes is because, sometimes there could be a fourth, sometimes there are two, sometimes there's five. It really just depends on the app. But the overall premise is you have a layer or a tier that does presentation. So this is like your mobile app, your web app. Then you have a logic layer that does things like place an order, ship an order, all the business intelligence. Then you have a data tier, which is your database or storage. So throughout these examples, I'm going to be using a fictional company that most of us know about that starts with an A and ends with an M for ordering online stuff. So if I was building that particular site, let's just give it a random name like Amazon.com. In this particular case, I would have a data tier that stores like my product list, my customer/client information, my ordering, as well as shipping information and stuff. And then the logic tier handles that interaction. So how do I place an order and how do I ship an order? The reason why they're separate from the database and the presentation layer so that you can make changes to them as well as test it without affecting the other applications. Then the presentation tier is just that. This is how you present the stuff to user. So your mobile app or your web app. Some of the advantages of this platform or this pattern is separation of concerns. You can minimize dependencies across the board. You can make development a lot easier in your world. It's testable, it's reusable, but some of the disadvantages of it is that when you change your model, like you change your database model, it tends to have ramifications in the logic tier as well as a presentation tier. Sometimes in your application, it might generate a lot more code because you're building out basically 3 projects or 3 pieces of your application. And then probably one of the most common things is debates as to where the code, quote unquote, belongs. Sometimes like validation logic is a common example. People want People say it should belong in a logic layer. Some people say it should belong in the presentation layer. So those debates happen on a regular basis. The next pattern we're going to look at is the model view star. And the reason why it's star is because there's a couple of different names. It's commonly used in the Microsoft world as model view controller, but there's also some slight variations of it as model view presenter, as well as the model view model. Difference between them is the model view presenter is kind of like the in between the controller and the view, whereas the model view model, the view model kind of sits in between. So let's talk about this one a little bit. So if you're looking at that website, a user comes to the home page, let's say Amazon.com, and they're presented with the view. So the user sees this view. In order to generate that view, the controller has to say, here's the content for that particular homepage. So it goes and provides a model to it. That model can include things like a list of the products, my shopping cart, my name. So it says, hey, Joe, here's 5 items in your shopping cart. Here's a list. So that model is then sent off to the view to create that user experience. And let's say I see these awesome pair of pink socks that I love. I click add it to the cart. I then, once I do that, that generates another controller call that says, oh, Joe added these items to his cart. I know what that looks like. Let me go and update his cart now with that purchase or with that item added. Now the model comes back with one item in the cart, those pink socks. And then the view gets updated. It says, oh, he has an item in his cart. Let me show that little side view that kind of gives the details of that item. And it goes back and back and back and forth, basically a circle around. This framework is really popular in a lot of different software development languages like ASP.NET, Spring MVC, Ruby on Rails, etc. Some of the advantages of this pattern, you have the separation of concern still, because you can have a team that just does the view, a team that just does the back-end logic. The presentation also tends to be more reusable because you can break it down into pieces and then share those pieces like the shopping cart across or the product view or product info pages. This also allows you for specialized roles. I can have graphics designers and UI designers working on the view piece of the application and software engineers working on the controller piece of it. One of the disadvantages of this pattern is if you don't have those specialized roles and you have your typical quote unquote full stack engineer, it makes it a lot more challenging for you because you have those two separations of duties. The next system gets a little bit, or the next pattern gets a little bit more, I don't want to say complicated, but more in depth. This is the event-driven pattern, commonly referred to as event sourcing or publish subscribe, or sometimes shortly called PubSub. For those of you who've been doing software development with Microsoft a lot, this is basically Windows Forms. You click a button, an event happens, you do something with it. But the primary thought between event-driven is you act towards events. So there are toolkits like Kafka, Akka, Azure, and others that provide this. So in the scenario where I'm ordering those pink socks, an event gets triggered, an order placed. So it says, hey, Joe ordered a pair of socks. So we have these subscribers to the events, like account charge. Account charge says, okay, I'm gonna charge Joe the $9.99 for that. Then I'm gonna go and check the inventory to make sure that we have pink socks available for Joe. And if we do, we're then gonna go and deduct from the inventory said socks. After that is done, we're then going to fire off another event saying, hey, the order is ready, which is this one here. Now that the order is ready, I'm going to go and ship the package and then update the order. Now, these are not necessary. They don't have to be serial like this or synchronous, do account charge, inventory check, inventory deduct. I just laid it out this way so it's easier to visualize. Some of the benefits of an event-driven architecture, it's distributed. You can have asynchronous processes go out, like if you're on Facebook or Instagram or TikTok and you like a video or like a post, it doesn't actually go and instantly like that post across the board. It says, hey, blah, 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 Joe liked this post. Okay, I care when Joe likes a post. So I'm going to go and send off a message off to the database to say, hey, store that Joe liked that post. And then I'm going to update everyone that's watching that post that there was a new like. So I'm going to increase that little heart number by 1, 2, 3, 4, etc. So it allows you to build a more distributed, more instant, quote unquote, application because you're able to distribute your load across. Common implementations of this are things like message queues, message topics. There's a lot of different providers for this pattern. Azure Messaging, Azure Service Bus, Azure Event Hubs. In AWS, you have the SNS or Simple Notification Services, Simple Queue Services, EventBridge. There's some older ones like IBM, MSMQ. The next pattern we're going to talk about is kind of an evolution of this pattern called the CQRS pattern, or Command Query Responsibility Segregation. So this pattern is the model that's used to read information, aka this side, is separated from the model that's used to update the application, aka this side. In a more traditional architecture, you have a single model that does both reads and updates. But in the command query segregation principle, the idea is you have one section of the application or one part that handles anything that requires updating and one that requires the querying or reporting. So let's go through a little bit about what this does. So let's say we have that same user interface here, the Amazon.com. I go and I update my cart and I want to purchase the item. So there's a command or an event that goes on the command bus that says, hey, I have a request to purchase an item. That's here in the command bus. And the command handler says, oh, I know how to handle that, or I care about handling when someone purchases an item. I go and do a bunch of stuff, with domain models. That's this particular case. We go back a slide or two. I'm going to place the order. I'm going to deduct money from Joe's account or charge his credit card. I'm going to deduct an item from the inventory. Then I'm going to mark it as ready to go. That kind of stuff then gets written off to some repository. And the repository could be a database. It could be a Cosmo DB. It could be anything. It's basically some way to store that. When that storage happens, though, there are two things that also happen. There is the event store. So the message or the command is stored so it can be played back at some point in time for the event of disaster recovery or some outage that you have to kind of replay the history of things. The other goes to another event bus, which basically says, oh, an item was removed from inventory, or an item was sold, or an item was returned. Then there's additional event handlers that go and say, oh, I need to know about when an item is there. Then it updates, whatever your data store is, SQL Server, Cosmo, etc. So now when I go back to Amazon.com and check my order, I come across, the interface, and now I go to the query side of it. Now I don't go there, but behind the scenes, the code goes through the query and says, oh, Joe wants to know where his pink socks are. Let me go through the data layer and figure that out. So it allows you to separate out the saving, editing, modifying of the data from the actual querying. That has a couple of advantages, but some disadvantages to it. One of the biggest advantages, it handles more complex things. So something like an Amazon that has millions of transactions a second can handle this because you can scale up the command bus, command handler, scale up these things and spread out the workload across machines. You can improve performance. There's always an asterisk, right? That it really depends on your design, your implementation, how much data you're passing, the servers you're using, etc. Security can also be a lot easier with this approach because with CQRS, you have the command handlers, you have certain permissions for things coming down this aisle and certain things coming down this aisle. Some of the disadvantages to it is it's kind of overkill for your basic CRUD app, the create, read, update, delete apps. If you're just building a contact database to manage your contacts, then you probably don't need this. Sometimes, depending on how you implement it, the data can be a little stale. Like I can go and add an item, comes down here. By the time it gets to here, I might not see it fast enough, or there could be updates that are being made that generally have not been processed yet. And I say could because that really just depends on how your infrastructure is as far as your network pipelines and your data stores and how messages are done and how much querying time you do to it. The other challenge, which is generally a big concern with CQRS pattern, is how do you get data synchronized across? So you have these repositories here that store data. Ultimately here, how do we make sure that's synced? Or as we start scaling this out and moving queries to one set of servers, how do you keep that data across the board? There are some tools in the .NET ecosystem that enable this relatively easily, and Service is one of them. Next, I'm going to talk about a combination of the CQRS and event sourcing. This one is pretty similar to the last pattern. It's kind of like the last two patterns, this one and this one combined. So the idea is you have your clients. Clients want to do something. Left side is I'm going to place an order. The right side is I want to query. The only difference is, you see here we have command handlers and query handlers. They're all working on an event bus. So there's an event bus in between the query engine and the event store. So like here, this event bus. But this thing has event subscribers and handlers that work with the data between them. And this can also send out messages to other things like reporting or data warehouse and stuff. So this extra layer adds some more flexibility as far as how the items talk to each other across the board. Now we're going to move into a more common one for the applications, desktop or mobile UI applications. This is a common pattern, the plugin or micro kernel implementation. These are generally used for apps that you want to write, that you want to extend, allow others to write. It's very useful when your app has a core set of responsibilities or a collection of interchangeable pieces. A common example of this is like a task schedule. The microkernel or the application itself can hold all the logic for scheduling and triggering tasks, but the actual plugins do it. Another great example of this is, let's say if we build Amazon.com in a app, in a desktop app and not in a mobile app. You have the application itself that kind of knows. You build out an inventory component, an account component, an order component, and a shipping component. And then the app knows it has to talk to each of these. The problem with that, or one of the challenges or cons with that, is that the application has to be smart enough to understand how to work with all of these in the Amazon.com or e-commerce example. But we actually use apps, like I'm using an app right now to display things to you called PowerPoint, that has a plugin architecture. So PowerPoint has the ability to add add-ins. The same thing with Word, the same thing with Visual Studio and Visual Studio Code. All the extensions that we use are following the plugin pattern. So Microsoft created a extensibility model for Visual Studio Code, as well as the Office suites of products that let you improve and adapt the environment. So you can do things like unit test cases or code quality or refactoring your code, things that Microsoft didn't build into a platform. You have the ability because they implemented a plugin or microkernel architecture. Next that we're going to talk about is a very common one. It was just very big in the 2000s and still is big today, although we're starting to see that we overuse this pattern a bit much, and that's the service-oriented architecture, or SOA, or microservices. It's basically an architecture pattern for developing software systems by creating loosely coupled apps that work together to automate some processes. So if we go through our e-commerce example, Acme Widgets, aka Amazon, I would have an account service. The account service would do things like build my account, show me a list of orders, update my address, that kind of stuff. And then the inventory service would have things like deduct the order, check the status, deduct an item from the inventory, check the status of an item, give me item details like the color of the socks, the size, blah, blah, blah. And then there's the shipping service that's responsible for sending the items or tracking the packages. And then there's the order service, which is responsible for the billing and calling everything else. So in my example of ordering the socks, the Acme would just say, oh, okay, we have Joe here. Joe wants to order socks. Let's go check the inventory to see what kind of socks we have. Provide a list of socks to Joe. Joe wants to order one of the pink socks. He's going to go back and order the pink socks. So the inventory service is called again. Now that he's done, we ordered it. The order service may call the inventory service to say, hey, deduct this item. The order service may also call the shipping service to say, hey, we need to ship these socks to Joe. Now, one of the advantages of this is these services, as long as they have a contract, which is required, in order for Acme Widgets to call them, you can change the underlying data and the underlying infrastructure without affecting the app. So let's say I start off and I make my own socks. So I do it out of my office at home or my garage, and I'm creating socks like crazy. So I go and I generally put them into the U.S. Postal Service for shipping. But now we start to grow. I'm shipping internationally, or I'm shipping more than I can do now. So I can update the shipping service to not only ship to the U.S. Post Office, but I can ship to things like UPS or Federal Express or DHL or whatever service I do. The Acme Widgets main app doesn't really care. It says, oh, give me an option for a list of shipping services I can provide to user. Okay, ship to this one. So it gives me the flexibility without having to update here. Some of the other advantages of it increases alignment between the business and technology, promotes federation within an organization. So I can have an account service, I can have an inventory service, I can have a shipping service. It also allows for vendor diversity. Like I said, with the shipping service, I can now use the post office, I can use UPS, I can use whichever ones I want. It also works with agile development practices. So I can build out my contracts here and then make them available so this team can start working on how they're going to display those items or work with it while this team is actually building out the services. Like I said before, one of the disadvantages is it can be over architected, meaning we can create hundreds and hundreds of microservices, making them too specific. The happy balance with this one is really finding out where that sweet spot is for your capabilities. And that's why I kind of listed them here as account service, inventory service, shipping service, and orders, because they kind of grasp a section of capabilities. I could have built out a account lookup service, an account update service, an account removal service, but that's just too much, in my opinion. Next one we're going to talk about is, now that we're in the microservices or service oriented, we're going to talk to some ways and patterns that you can go and make implementation of this a little bit easier from an older legacy system to a more modern system. So we're going to cover a couple different patterns in this one, and I'll highlight them as I talk about them. So think of this as, we built out Amazon.com, where I was working out of my garage. Everything sat on one PC sitting in my garage. And now I've realized it's getting too much. I shouldn't have everything on one PC. So I'm going to start building it in a way that allows me to scale it out easier. So this is my client, my new client application. I'm building it. Technology doesn't matter, but let's say ASP.NET, and I'm hosting it in the cloud like Azure or AWS. And this is my legacy system that's sitting in my garage that has everything in it. So there's quite a few patterns here that kind of work together. First off is the Strangler fig prop pattern. Now this is based off of a actual plant that kind of, it grows vines around the tree and eventually covers the tree, ultimately killing the tree, but using the tree's trunk as infrastructure for its growth. This allows you for ways to ultimately incrementally improve your app. So as you're writing off pieces, you're removing them from the legacy system and going forward. So the client application can say, hey, Strangler, where am I going? Am I going to the new way or the old way? Meanwhile, you can also still have stuff going here. So the first thing you see in our microservice application, let's just assume this is the account service for now. We have this gateway offloading pattern, which basically allows the microservice to offload shared functionalities such as SSL certificates, API, gateway monitoring, that kind of stuff. Then it goes into the gateway routing and gateway aggregation patterns. Now, the gateway aggregation kind of takes multiple individual microservices and putting them into a single request to enable some better performance by sending one request versus hundreds. The gateway routing kind of takes multiple requests using a single endpoint, so it doesn't necessarily go out to multiple. So it will handle kind of which services or which service to go. These then call something generally called a BFF, which is not best friends forever, but backends for front ends. These are basically specialized APIs that can be aggregates for others. They could also display data differently depending on the client. So if you have a mobile client versus a web client, for web client, you might want to provide some more rich data like full-size images, client's full name, their address, that kind of stuff. But for a mobile client, you might want to find a mobile optimized image, a lot smaller, a smaller size image, as well as maybe just first name and last name and not the full address. So the backend for front end kind of tweaks and aggregates the data from the different microservices there. You also see the sidecar and the ambassador patterns here, and they're not really attached to anything, but they make up this overall microservice. So the sidecar deploys helper methods for the application, such as separate containers and processes to isolate and encapsulate. So you can think of this as something like Docker. So you can containerize this, and then that kind of hosts your app and lets you do what you need to do with it. Then you have the ambassador pattern. The ambassador pattern is used to offload some common client connectivity stuff, such as your monitoring, your logging, your routing, security, language specific stuff. Also handles connections out to remote services that are not part. So like if I was building the shipping service, that could be here, the ambassador would help with the negotiations to, let's say, UPS for tracking updates. Then one other pattern we haven't talked about with the anti-corruption layer, and no, that's not to help with politics or anything, but the anti-corruption layer is basically a facade that goes between your legacy system and your new system and kind of keeps them in sync to make sure that these apps, as you make changes to here, you're not affecting here, and vice versa, that these apps are more in sync. So as we talked about, I'm modernizing my app from moving from legacy systems over to a new client server or cloud-based one, which leads us to our next pattern called serverless. Now, the serverless pattern, or the cloud, or basically not on my PC, is basically it's a pattern that uses third-party services like Azure, AWS, Google Cloud to manage the complexity of the servers. So as a app engineer, I don't necessarily want to know what services I'm running on or what servers. If I can say, here, Azure hosts this website for me, great. I don't have to manage the operating system patches, the network bandwidth, that kind of stuff. I may have to manage how many instances I have, but it also allows you to take away some of the work you have to do. And that's why it's listed as a pattern. Some of the other things you could do is like backend as a service or functions as a service. It's basically will offload everything from your group to another responsibility. So we covered about 10 patterns, and what I'm trying to provide to you is a toolbox. Remember the phrase, if the only tool you have a hammer, you tend to see everything that's a nail. If you get anything out of this talk outside of Joe is a great presenter, you should get out of here a list of patterns. Now, I don't want you to go back to your desk, or as the conference continues, when it's done, go back and say, oh, Joe talked about this event-driven thing. Let's go and update all our applications to event-driven, or let's follow the plugin for all of our apps. No, that's not the thing. Remember, just because you have a hammer, everything isn't a nail. Find the right tool set for it. Each one of the patterns I've talked about has a reason for using them. They all have pros, they all have cons to it. You have to find what's best. This is more of here's a selection to choose from. pick the one that's right for you. And there isn't a right answer. It isn't, if I'm building a website, everything should be model view controller, or everything should be layered, or everything should be plugged in. There's a lot of it depends. As you start maturing in your software development, you'll notice that you'll see yourself following certain patterns, or some patterns help more than others with your development.